Hello there guys, welcome back to another epic inexorable maths video. In this video we're looking at something called Thales theorem. That is how you pronounce it, Thales. It's not Thales or Thales, it's Thales theorem. Thales was a very ancient mathematician and he came up with this thing, a circle theorem from GCSE maths that we have to know about. So it is Thales that allegedly did come up with this. Some people say that Pythagoras came up with this, but it's not called Pythagoras' theorem because that is already taken. So we call it Thales theorem. What does it say? If AOB is a diameter of a circle, then for any point C on the circumference, the angle ACB is a right angle, 90 degrees. Okay, so here's the picture. Very famous. A lot of people know this just by looking at it. But if I move C to any point along the circumference, then the angle between A, C, and B would be a 90-degree angle, okay? I suppose with the exception of C literally being on top of the point B or A. But with the exception, as long as they are unique points, this is true. So how do we prove it? Well, guys, it's actually really not too bad. So let's go straight in and do it. So what I'm going to do is I'm going to slightly rub this out. Okay. And I'm going to say that I don't know that that is a right angle. That's what I want to prove. I want to prove that it's a right angle. So what I do is I'm going to draw a line to the origin like that. Now, I know a few things about the triangle that I've just made, AOC, that triangle. Because O is at the center of the circle, this distance is whatever the radius of the circle is, and so is this distance. They're both the radiuses or radii of the circle, so they're the same length. Because of that, we know that AOC is a isosceles triangle, okay? Which means that whatever this angle is, I'll call this angle X for now, is the same as this angle here. So that's also X, I will call it, okay? That also means that this angle, because the angles inside of a triangle add up to 180 degrees, this angle here, I'll label it down here, is a 180 minus 2x degree angle, okay? So that they all add up to 180. We can now do the same thing for the other triangle. I also know that the distance from O to B is a radius of the circle as well. So that triangle there, OBC, is also an isosceles triangle, which means if I say that this angle here is maybe Y, then this angle up here is also Y, which means that this angle here is a 180 minus 2Y degree angle, so that all of the interior angles in that triangle add up to 180 degrees. So now we can see that this angle and this angle should add up to 180 degrees because they're on a straight line, okay? So this angle and this angle. So if I write these two angles added together, the first one is 180 minus 2x, and the other one is 180 minus 2y. This should be a 180 degree angle, okay, because it's two angles on a straight line, okay? Then, by rearranging this slightly, I'll cancel out two of the 180s, okay, and slightly rearrange this to get, if I add 2x to both sides, I add 2y to both sides, I'll get 2x plus 2y equals 180 degrees. Dividing both sides by 2, I get that x plus y is 90 degrees. 90. Now, why does that matter? Why is that so great? Well, this angle up here is the angle x plus y, which means this whole big angle here, the angle ACB, x plus y, is a 90-degree angle, okay? Therefore, this is a right angle. And this would work if C was anywhere along the circumference. We didn't make any reference to where C is, so this would work anywhere for any location that C is around the circumference of the circle. Thank you guys so much for watching. As always, I highly appreciate it, and I'll see you in the next video. Cheers.